Good morning, Sarvani. I'm CHOO ZHONG SIONG. Today, I will be presenting my experiment entitled Relationship between Pendulum Length and Period of Oscillation. This experiment was conducted as part of the XEX 1142 Mathematics in Science course. The purpose of this experiment is to investigate how the length of a simple pendulum affects its period of oscillation. In addition, I compared two different pendulum bob masses, which are 20 grams and 50 grams, to determine whether mass has any effect on the oscillation period. Through this presentation, I will explain the theory behind the experiment, the methodology, the experimental results, and graphical analysis, and finally, my conclusions. Before discussing the experiment, let us understand what a simple pendulum is. A simple pendulum consists of a small object called a pendulum bob suspended from a fixed support using a light and inextensible string. When the pendulum is displaced slightly from its equilibrium position and released, it swings back and forth due to the gravitational force acting on it. If the angle of displacement is small, usually less than 10 degrees, the motion closely follows simple harmonic motion or SHM. Simple harmonic motion is a type of periodic motion where the restoring force always acts toward the equilibrium position and is proportional to the displacement. Because of this property, the simple pendulum is widely used in physics to study oscillatory motion and to determine the acceleration due to gravity experimentally. The motion of a simple pendulum is described by the equation T equal 2 pi multiplied by the square root of L over G. In this equation, T represents the period of oscillation, L is the length of the pendulum, G is the acceleration due to gravity. From this equation, we can make two important observations. Firstly, the period increases as the pendulum length increases. This means that a longer pendulum requires more time to complete one oscillation. Secondly, the mass of the pendulum bob does not appear in the equation. Therefore, according to the theory, changing the mass should not affect the oscillation period. This prediction forms the basis of my experiment where I compare oscillation periods of 20 grams and 50-gram pendulum box. The main aim of this experiment was to investigate the relationship between the length of a simple pendulum and its period of oscillation. To achieve this aim, several objectives were established. The first objective was to investigate how the pendulum length influences the oscillation period. The second objective was to compare oscillation periods using pendulum bobs with masses of 20 grams and 50 grams. The third objective was to verify whether the mass affects the oscillation period. Finally, I aim to determine the experimental value of gravitational acceleration using graphical analysis and compare it with the theoretical value. These objectives allowed me to verify the principles of simple harmonic motion experimentally. Now, let us look at how the experiment was carried out. First, the apparatus was assembled using a retort stand, a clamp, a light string, a pendulum bob, a measure ruler, and a stopwatch. The pendulum length was measured carefully from the point of suspension to the center of the pendulum bob. The pendulum was displayed by an angle of approximately 5 degrees before being released without any additional force. The time taken for 10 complete oscillations was measured twice using a stopwatch. The average time was then calculated to minimize random errors. Next, the period of oscillation was obtained by dividing average time by 10. The square of the period was also calculated for graphical analysis. The entire procedure was repeated for pendulum lengths ranging from 20 centimeters to 80 centimeters. Finally, the same procedure was repeated using the 50-gram pendulum bob so that the two sets of data could be compared. The table summarized the experimental results. From the data, we can clearly observe that the period of oscillation increased as the pendulum length increased. For example, using a 20-gram pendulum bob, the period increased from approximately 0.895 seconds at a length of 20 centimeters to 1.775 seconds at 80 centimeters. Similarly, for the 50-gram pendulum bob, the period increased from 0.86 seconds to approximately 1.78 seconds. Although the measures were different, the record period were very similar. This suggests that this suggests that the pendulum length has a significant influence on the oscillation period, while the mass has little or no effect. These observations agree well with the theoretical prediction discussed earlier. To future analyze the result, graph were plotted using the experimental data. The graph of t-square against pendulum length produced an approximately straight line with a positive gradient. This is an important result because the theoretical equation predicts that t-square is directly proportional to the pendulum length. Based on the results, we found that increasing the pendulum length caused the oscillation period to increase. This occurs because a longer pendulum has a larger radius of motion, meaning the pendulum bob travels a greater distance during each oscillation and therefore requires more time to complete one cycle. In conclusion, this experiment successfully achieved all of these objectives. The results demonstrate that the period of oscillation increases as the period length increases. The experiment also showed that the mass of the pendulum bob has no significant effect on oscillation period. The graph shows and also produce an approximately straight line, confirming the theoretical relationship predicted by the simple pendulum equation. Thank you.